Hello everyone, good morning to all of you. Myself Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today in this lecture, I am going to discuss about the solution of question bank from Module 3. In Module 3, I want to discuss about the Part C. In Part C, I want to discuss some definitions of the given topic in Module 3 and short answer type questions. So, I want to explain every topic, every content clearly. First of all, I want to suggest two references of test books which are given as follows. These books are very important for the engineering mathematics in semester 2nd. The first number of reference of test book is first the name of the authors are N.P. Wali and Manish Goyal. Publication of this reference of test book is publication Lakshmi Publication Private Limited. And second reference of test book is the name of the authors are H.K. Das and Dr. Rama Verma. Publications S. Chand and Company Private Limited. So please, you can follow these following given books which are very important for this paper. Next, I want to discuss here some definitions and short answer type questions in part C. Okay. So now, first we want to discuss question 1. In question 1, I define definition of order and degree with reference to partial differential equation. How we can check the order and degree of a differential equation, partial differential equation. So here we want to discuss this topic in detail. First of all, I want to discuss what is partial differential equation. What is partial differential equation? After define partial differential equation, then we discuss about the order and degree of a partial differential equation. So here solution first define partial differential equation. Partial differential equation. So in a differential equation, first define partial differential equation. In a differential equation, there are three variables. In a differential equation, there are three variables. There are three variables: x, y, and Z. Okay. Z, X and Y are independent variable where X and Y are independent variable. Independent variable. And Z is dependent variable. Z is dependent variable. Here Z dependent on X and Y. So here we can say that Z is the function of X and Y, or in mathematical form Y is equal to function of X, Y. Z is equal to is the function of X, Y. So here X and Y are independent variable. I want to discuss you in a differential equation, partial differential equation, there are three variables X, Y, Z. Here in this chapter, I am discussing in this chapter, there are three variables in a partial differential equation. X and Y are two independent variables and Z is dependent on X and Y. We are discussing only two independent variables in a partial differential equation. What is general partial differential equation? There are more than one independent variable. It means there may be an independent variable in any partial differential equation. But in our this module 3, in partial differential equation, we are discussing those partial differential equation in which only two independent variable X and Y, and Z is dependent variable on X and Y. So Z is a function of X and function of Y. Z is the function of two variable X and Y. So the derivative of Z with respect to X. So differential of Z with respect to X. Then we can write Y is constant. Y is constant. Then we can write dou Z over dou X. This equal to dou F over dou X. And this equal to small p. Okay. Now this is point 1. Point 2 is differential of Z with respect to Y. X is constant. Is a constant. Then we get here dou Z over dou Y equal to dou F over dou Y. This equal to Q. This is point 2. Point 3 is differentiating of Z with respect to 2 times. Then we get dou 2Z over dou X2. This equal to dou 2F over dou Z X2. This equal to R. Basically, this represent Y dou P over dou X, or we can say R. Okay. Here dou 2Z over dou X2. This equal to dou over dou X of dou Z over dou X. This is P. So dou over dou X of This is P. We can say dou P over dou X. And this is represented by R. R is dou 2 Z over dou X2. Now third point is 4. Again, differentiating Z with respect to Y. Then we get dou 2Z over dou Y2 equal to dou over dou Y dou 2F dou Y2. This equal to dou over dou Y dou F over dou Y, and this equal to dou over dou Y, and this is Q. Then we can write here dou Q over dou Y. This is T. Dou 2 Z over dou Y2. This equal to T. Okay. Fifth point is differentiating of Z with respect to X and Y. Okay. So we get here. So here dou 2 Z over dou Y dou X. Or we can write here dou 2Z over dou XY. Both are equal. This is the property of partial derivative. Okay. This is the property of partial. This is the property of partial derivative. Okay. So this is equal to each other. Now next, here point 5. Dou 2Z over dou Y dou X. This equal to dou 2Z over dou X dou Y. Both are same. This is the property of partial. Then we can write dou over dou X and dou Z over dou Y. This is Q. So dou over dou X and this is Q. Means dou Q over dou X. This result is equal to dou 2Z over dou Y dou X. Dou X dou Y. Dou X and dou Y. So this result is equal to S. Or we can write this result dou 2 over dou Y. Dou 2 over dou Y. Dou 2Z over dou Y2. And here is dou X. Dou over dou Y. Here is dou Z over dou X. This is P. Dou over dou Y. This is P. So dou P over dou Y. Okay. This is also S. Or we can write here dou 2Z over dou X dou Y equal to dou 2Z over dou Y dou X, and this equal to capital S. Okay. So these are the basic point and very important for partial differential equation. Now, 6 point partial differential. What is PDE? What is PDE? Partial differential equation. So in a relation, in a relation, there are three variables x, y and z. Z is a function of x and y. Z is the function of x and y, and a derivative, a partial derivative, a partial derivative involved in this relation. Then relation is called PDE. Okay. In a relation, there are three variables x, y and z. Z is the function of x and y, and a partial derivative involved in this relation. Then relation is called partial differential equation. So here I am giving several examples in partial. Now different examples of partial differential equation. Examples of partial differential equation. Okay. d2z dz over dx, dou z over dou x plus x square equal to sin x. Dou z over dou y equal to plus y square equal to cos y. Dou z over x, dou z over dou x plus y, dou z over dou y and equal to z. So these are different examples of partial differential equation. Now next one is x dou 2z over dou x2 plus 2xy dou 2z over dou x and dou y plus y square dou 2z over dou y2. So these are all different examples of partial differential equation. Now what is order? I define order of a differential equation. Next order. What is order of a differential PDE? Okay. In a differential equation, in a PDE, we see that how many maximum time differentiate z with respect to x and y. That is called the order of PD. This is order of PD. Now next degree. What is degree? What is degree? Degree of PDE. So here we see that the power of highest order derivative, highest order derivative in a PD, then the power is called degree of PD. Okay, we given here several examples of order and degree. So examples first, x dou z over dou x plus y dou z over dou y equal to z. This is the order is 1 and degree is 1. First order and first degree differential equation. This is the order is 1 and degree is 1. Order and degree is 1. Next here x square d2z over dx2 plus 2xy d2z over dx dy dou x and dou y and plus y square dou 2z over dou y2. This is 0. This is homogeneous partial differential equation. Order 1 here and degree also 1. Order 1 and degree 1. Okay. Now next. Form the partial differential equation from eliminating the arbitrary constant from this function. Solution. Here, formation of PDE after eliminating the given function. Okay. Here, formation of partial differential equation after eliminating the given function. A function is given, a function or constants. So now function is given z equal to ax cube and plus by cube. This equation 1 function is given. Here differentiating with respect to x to equation 1 y as a constant. Okay. Then here dou z over dou x. Here y as a constant. So y differential of y is 0. So here a into 3x square. And this result 0. So this equal to 3ax square. Dou z over dou x. Okay. Now we find here a equal to 1 upon 3x square and dou z over dou x. This is equation 2. Again differentiating with respect to y to 1 x as a constant. Okay. Though we get dou z over dou y, this is equal to b and 3y square. Now after simplifying, b is equal to 1 upon 3y square dou z over dou y. This equation 3. Putting value of a and v in equation 1. Putting value of a and v in equation 1, then we get z equal to ax cube plus by cube. So z equal to a, what is a? 1 upon 3x square and a and dou z over into x cube and dou z over dou x plus 1 upon 3y square and into y cube and dou z over dou y. So this cancel to this cancel to this, and multiply by 3. 3z equal to here x, dou z over dou x, plus here y, dou z over dou y. Okay, this is the given, this is the required partial differential equation, PDE, partial differential equation. Okay, now next problem second, third solution. P minus Q is equal to log x plus y. This is equation 1. This is a linear Lagrange linear partial differential equation of first order and first degree. Okay, first order and first degree. So here basically we see that P minus Q equal to log x plus y. This is equation 1. But general equation capital PP plus capital QQ equal to R. This is equation 2. Equation 2 is general Lagrange. Equation 2 is a general Lagrange linear partial differential equation. Partial differential equation. Okay, general linear partial differential equation. Compare in 1 and 2. Comparing in 1 and 2, then we get here P is 1, Q is 1, Q is minus 1, P minus Q, Q is minus 1, and R is log x plus y. Okay, this is 3. Now auxiliary form of 2 is dx upon P dy upon Q equal to dz upon R. Now putting PQR, putting value of P, Q and R in 4, then dx upon 1 dy upon putting value of P, Q, R in 4. Okay, then we get an auxiliary equation of 1 dx upon 1 dy upon minus 1 and dz upon log x plus y. Okay. Here taking first and second fraction, first and second fraction, dx upon 1 dy upon minus 1, integrating on both sides. So here x equal to minus y plus c1 plus c1. So x plus y equal to c1. This is first solution. Solution 1. This equation 5. This is 6. Okay. Now taking first and third fraction. Third fraction. So dx upon minus y, dy upon minus 1, sorry dx upon 1 equal to dz upon log x plus y. Okay. Here apply formula finding second solution with the help of first. Apply formula finding second solution with the help of first. Help of first. Okay. So now integrating this, here writing dx upon 1 integrating and equal to dz upon log c1. This is c1 and integrating on both sides. Here x equal to z upon log c1 and plus c2. Putting value here c1. Now here solution 1 dx upon 1 equal to dz upon log x plus y. Integrating on both sides. So dx equal to dz upon log c1. So c1 is constant. Here is x equal to z upon log c1 plus c2 another constant. Now putting value of c1, putting value of c1. This equation is 7. Putting c1 in 7. Then we get here x equal to z upon log c1 is x plus y and plus c2. This minus this equal to c2. This equation 8. Okay. Now complete solution is of 1 is now complete solution of 1 is function. First solution is x plus y, comma x minus z upon log x plus y. This equal to 0. So this is the solution. Combination of first and second. Basically, this equation is known as a Lagrange partial differential equation of first order, first degree. Then first of all, we find out an auxiliary equation of equation first. Then there are 3 fractions in auxiliary equation. So at a time, we take any 2 fractions, first, second, or second, third, or third, first. So after taking fractions should be variables are separate. But here we are taking first and second fraction. Then we see that Variables are separate. Then we find first solution. Now second solution finding with the help of solution first. Solution first is x plus y is c1. X plus y equal to some arbitrary constant. So finding second solution, then we putting the value of x plus y equal to c1. After integrating, again we putting the value of c1 equal to x plus y, then we get complete solution. Next solution is p plus 3q equal to 5z plus 10 y minus 3x. This is equation 1. This is also Lagrange differential equation. This is Lagrange differential equation. Okay, Lagrange differential equation. Lagrange is capital PP plus capital QQ equal to R. This is equation 2. Now auxiliary equation of 1. Auxiliary equation of 1 is dx upon 1 dy upon q3 and dz upon 5z plus 10 y minus 3x. This is equation 3. In equation 3, we get three fractions. Now taking first and second. Taking first and second fraction. First fraction dx upon 1 equal to dy upon 3. Variables are separate. Here variable integrating on both sides. This implied that here is x equal to 1 upon 3y plus c1. So here plus c1. Now 3x c1 adding this side. Here equal to plus c1 y3. This is arbitrary constant. Multiply 3, then we get here 3x minus y equal to c1. This is solution 1. This is solution 1. First solution this. Equation number is equation number 4. This is fourth equation. Now taking fraction first, fraction 1 and 3. Then we get here dx upon 1 equal to dz upon 5z plus 10 y minus 3x. Okay. So here dx upon 1 equal to dz upon 5z plus 10 c1. Putting value of putting x minus 3y equal to c1 from 4. X minus 3y equal to c1 from 4. So we get this integrating on both sides. So here is x equal to 5. Here 1 upon 5 log 5z plus 10 c1. Okay. Plus log c2 is another constant. So we can write this side, taking this side 1 by 5 c1. So 5 is cancel, 5x minus log 5z plus tan C1. This equal to upon 5. This equal to log 1 by 5 and log C2. 5 is cancelled. So you are putting, this is second solution. Log e to the power 5x minus log 5z plus log x minus 3y and equal to log C2. So now we can write here log e to the power 5x upon 5z plus log x minus 3y equal to log C2. Log is cancelled. So 5 e to the power 5x upon 5z plus log y minus 3x 3x minus 3y equal to C2. This is second question. Okay. Now final solution is function in bracket first solution x plus y. Second solution is e to the power 5x upon 5z plus log x minus 3y and this equal to 0. This is complete solution. Next result is solution px plus qy equal to z. This is equation 1. Its auxiliary form, auxiliary form is dx upon p equal to dy upon q equal to dz upon r. This is an auxiliary equation. So now putting value of pqr. This is small pq. So here p is x, dx upon x, dy upon y and dz upon z. This is auxiliary equation of 1. This is auxiliary equation of 1. Now there are 3 fractions. This equation 2, this is 3. Now 3 is the auxiliary equation of 1. Equation 3 is an auxiliary equation of 1. So taking first and second fraction, then we get here dx upon x equal to dy upon y. Integrating on both sides, we get log x equal to log y and plus log c1. Now log x upon y equal to log c1. So log cancel, x upon y equal to c1. This is solution 1. Solution 1. First solution. Okay. Equation number is equation number 4. Now again taking second and third fraction. So here dx dy upon y equal to dz upon z. Integrating on both sides. So here log of y equal to log of z plus log c2. Log of y upon z equal to log c2. Log is cancelled. Y upon z equal to c2. This is solution second. Solution This is second solution. Now your final solution. Here complete solution of one is function form. First is x upon y, comma y upon z. This equal to c. This is equal to 0. Okay. This is the equation. Complete solution is this. Here we find first solution and second solution. Combination of first and second is the complete solution of Lagrange partial differential equation with constant coefficient. So this is the repeat question here. Same question repeat here. Okay. Px plus qy equal to z. Next question is 7. Solution. x plus y into p minus x plus y into q is equal to z. This equation 1. This is also Lagrange differential equation of first order and first degree. So we write here p into small p, q into small q equal to r. This equation 2. Compare 1 and 2. Comparing 1 and 2. Comparing in 1 and 2. So p is equal to capital P is x plus y and capital Q is x minus y. Capital Z is R is Z. Now auxiliary equation is dx upon p, dy upon q and dz upon r. Okay, this equation 3. This is 3 equation. Next is putting value of p, q, r. Putting value of p, q and r. So we get here dx upon x plus y, dy upon minus x minus y, dz upon z. This equation 4. Taking first and second fraction, taking first and second fraction. So here dx of x plus y equal to dz upon dy upon minus x plus y. So this is cancel here. Dx equal to minus dy. Integrating on both sides. Then we get here dx x minus plus y equal to c1. This is solution 1. This is solution 1. Taking first and third fraction. First and third fraction. Here dx upon x plus y equal to dz upon z. Putting x plus y, this equation number 5. So x plus y equal to c1. So here dx upon c1 equal to dz upon z. Integrating on both sides. So here x upon c1 equal to log z equal to log c2. C2. Final answer is here putting is this is answer second. Solution second. Okay. So the combination of solution 1, equation 5, this equation 6. Combination of solution 1 and 5 and 6. This is 5. Combination of solution 5 and 6 is the complete solution of the given Lagrange differential equation. Here, question problem 6 is repeat. So I am not discussing problem 6. We have discussing one time problem. Okay. Thank you. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.